Hello, my name is Alex Negri. I'm co-founder and CTO of Absolate, and I want to give you today a brief introduction of what is web isolation and how can you secure your SaaS applications, the web applications of the world, and against that data exfiltration, against data theft, as well as shield your corporate endpoints against malicious data that lives on the web. Let's first describe a little bit the problem we are looking at. As more and more companies migrate into the cloud and adopt applications such as Salesforce, Office 365, G Suite Box, so is their confidential data is moving into the cloud. And these companies need to give access to remote users, like employees working from home or contractors, needs to give access to these trusted applications from unknown endpoints, potentially untrusted endpoints, right? And the problem is, how do you make sure that none of the confidential regulated data that lives in this application, confidential information or regulated data, stays behind on these devices that you don't always control or own, right? And there's also a twist to it. Now, the opposite use case is, how do you make sure that users using your internal trusted devices, when they click on malicious links or malicious web content, they don't do anything to harm your internal corporate devices? Now you might ask, what do these two problems have in common? In both situations, the problem is that content can get out of the end user's browser into the endpoint of the user. In the first situation is good content that you don't want to leave behind on untrusted, unknown endpoints. In the second use case, in the second situation is bad content that you don't want to harm your internal corporate devices. Why this is a big problem? First of all, from compliance perspective, companies, especially in regulated industries, need to make sure that they are in control of their data at all times. Otherwise, hefty fines may be imposed. See HIPAA in the United States or GDPR in Europe. Secondly, security is very important because if somebody clicks on a malicious link and is compromising their endpoint, it can also compromise your internal IT infrastructure. See, for example, the Target attack that happened 2 years ago, which actually exploited a contractor's laptop. And usually the contractor is the weakest link because it's sitting at the edge of the enterprise and it's using an unknown endpoint, is a contractor's laptop. And last but not least, IP protection. Intellectual property is at risk when companies' data can be disclosed inadvertently, accidentally or unaccidentally, when somebody is willing to steal data from SaaS applications. Let me speak a little bit about the solution. What can you do to cover these two use cases? So one of the solutions is web isolation. Is a technology called web isolation. And web isolation is a technology that acts as a shield between your cloud applications and your end user's endpoint, so that all the applications, all the confidential data, for the example, for the first case, all the confidential data gets rendered in a secure and isolated container remotely, and only a safe, passive stream of pixels reaches the end user's browser. So in the first case, no confidential data can get out of the container. In the second use case, when you have malicious web content, any malware or ransomware that can live on the web and the user may access will never leave the container, cannot get out. So the user at the end of the day sees only a stream of pixels. Okay, no HTML, CSS, or JavaScript code ever reaches the endpoint, nor any data that he or she may consume using the cloud applications. How can web isolation help you? Well, one of the most important use cases of web isolation is preventing websites from delivering zero-day malware and phishing threats to the user's devices. Because the web isolation takes a completely different strategy. It protects, it isolates, it does not detect. So we are not in the business of detecting the threats, we are in the business of isolating, and making sure that if there is a malware, there is a threat, it will not leave and get to the endpoint, to the computer of the end user. Also, one of the use cases is blocking certain sites, certain uncategorized sites in enterprises. Like companies usually nowadays use secure web gateway proxies or intelligent proxies that block uncategorized sites because they detect they are risky sites or they may contain malware. Some of this is true. Some of this is somewhere in the middle, is some of a gray list. And sometimes employees yell at IT because they have blocked now a site that they really need to access to get their job done. So you can also avoid overblocking certain sites by sending them through isolation. So you can give access to information where the sites are risky, and in the same way protect your internal corporate endpoints. And your employees will be much happier now because they can access. And for example, they can access social sites, right? Why do you have to block Facebook in your company? Why do you have to block YouTube? You don't need to block it. Just isolate it and give it access. Some other categories of employees, such as C-level executives or people working in the financial department or IT department, have access to very sensitive data. You want to protect their endpoints when they are navigating into the web. That's another use case. You want to protect them against web-based threats. Also, phishing attacks, right? So a lot of people nowadays are getting attacked through phishing techniques, right? That arrives on the email. So what if you could rewrite all the links that are arriving in your corporate email through the email gateway? You rewrite all the links and you send all the links through web isolation. In case there is a phishing attack, you can be sure that when an employee will click on a link in his email, in his endpoint, the link will be open or the site will be open in web isolation. If there is any malware that is being sent through that link or a phishing attack, you'll be sure that it's isolated from the endpoint and your assets are safe, basically. Last but not least, ransomware attacks can also be one of the potential way of attacking and isolating URLs that can be, let's say, through certain engines, certain technologies can detect that this is a potential ransomware attack. You can isolate only that URL so that it goes through a secure sandbox so that it does not leave, basically, and get into the endpoint. So it's all about protecting, at the end of the day, your computer when you are in an internal corporate domain, as well as protecting your data that lives into the cloud so it doesn't get into the wrong hands. Enough about business discussions. I'm going to do a short demo to see how it actually really works, right? So what I'm going to access right now, so I'm in my Chromium browser. This is a plain vanilla Chromium browser. It actually works with any HTML5 compliant browser. There is no extensions, nothing installed on the client. It's just a plain Chromium. I'm going to access our web isolation technology. Actually, let me start from the beginning to show you the authentication flow as well. Okay, so now we are starting. So when you start, we basically, well, yeah. I was already authenticated. I had the session, I think, previously. Anyway, we authenticate with SAML 2.0, so we integrate with any identity provider. So what you actually see here, it's already encapsulated. The experience, what you see here is just, it's a passive stream of pixels that reaches your endpoint. It's just images. And all the experience is currently rendered in a container remotely, in an isolated container remotely. So you can, browse your regular company application easily. You have a browser experience with the same capabilities as any experience. Whatever, for example, if you download something, let's go to Word, for example, and you can download something. Let's say I want to download this document. It will never reach my endpoint The download is being made on the container. So I can show you the downloads directory. The document was named Zavar docx. There's no Zavar docx here. So the document got only into the container, and you can open it, you can view it, as well as collaborate with it using Office 365. So if you are a company that uses Office apps already, you can use it freely. And also, for example, if you are, let's say you are a malicious employee and you want to exfiltrate this document that I just downloaded to another site, let's say upload files. I want to get it outside. If I try to upload this document into outside of my corporate apps, I will be blocked because I was basically restricted to only collaborate and work with my company applications. So again, web isolation helps us to, in this case, protect safe content that lives in trusted SaaS applications, your corporate applications that are living in the cloud, against data exfiltration, willingness, for example, or unwillingly. Maybe you worked on a document, you downloaded locally on your company device, and on your personal device, and you forgot about it. So this way, you can protect against this scenario, as well as unwillingly when you are trying to exfiltrate that outside. Of course, you cannot copy-paste from inside the container outside, or vice versa. These are security policies driven. You can relax or unrelax depending on what you really want to accomplish. And the second use case with the malware, I don't have a malware site right now, but if somebody has one, we can go ahead and access it. But the idea is whatever site you access here that may contain malware, either through a redirect or directly into the site, whatever it can do, it can only affect the container. It may compromise the container. Maybe it will destroy it, but we recreate a new session afterwards. So it will not affect any of your endpoint. This is completely isolated. You just see a safe stream of pixels. And last but not least, we are organizing a bug bounty. If you have not heard of it already, it has started since yesterday. We have total prizes of $1,000 and more. Our contest is centered around 3 major goals. So break the obsolete sandbox that you just saw on the screen. It can have different levels you can go through. Maybe try to get shell access to the container, maybe try to get shell access on the underlying VM, or try to exfiltrate the information somehow from that container. Also, ability to exfiltrate information, like I showed you. I was downloading a document from Word, and I was trying to upload it somewhere else. Maybe you can try to exfiltrate. You have other ideas how to get data outside of Word into other applications. And also ability to bypass authentication, because this is protected with an authentication system. The idea is how can you access corporate applications without going through Absolute? Because we basically shield the web applications. For example, we shield Office apps, Salesforce, so that accesses only go through Absolute. If somebody goes to Salesforce directly, it will redirect to Absolute all the time. So this is one of the challenges also. On the bug bounty, you can scan the QR code and find more information about it, as well as on the DefCamp website. And of course, to our stand, if you want to come to discuss in more details, you are welcome. We have a stand in the London and Bucharest area near the Orange stand. Thank you very much.
I'm a cybersecurity researcher and the founder of an Orange startup called DefCamp. My presentation for today is titled Lions and the Watering Hole. What if I told you there's a type of cyber attack that can infect your computer without you doing anything? No user interaction, no nothing. Just you browsing a legitimate website. It's called drive-by exploitation. It's delivered through a very stealth technique called watering hole. Some of you might have heard about it, but most people didn't. Instead, everybody's familiar with phishing attacks, spear phishing, or direct server or services attacks. but not very many people heard about the watering hole attacks. So, what happens during a watering hole attack? Basically, an adversary gains access to a system. Instead of attacking the servers directly, he attacks a user visiting a website through the normal course of browsing, just like predators are stalking prey in a real-life watering hole. Basically, the attacker compromises a website that a certain group of people normally visits and alters the HTML code in such ways that the users are redirected to an exploit kit who performs the actual exploitation. The actual exploitation will be or will not be performed against users depending on certain factors such as the user agent or originating IP addresses. And then the exploitation kit installs a malware implant inside the unsuspecting user's device, something like this. It can be delivered either through a normal website, uninfected, but with a malicious advertisement, through a compromised website, or even through a spammed link. The user is redirected to a traffic redirection system who then attacks him with the exploit server kit, and then it can install ransomware, banking trojans, or some other types of malware. This type of technique is currently the predilect technique used by APT groups, be it espionage groups or banking attacking groups. This technique affects all Unix systems, all Windows systems, all iOS, and all Android. Your phone is just as much as a target as any other computer. Nothing is safe. Recent high-profile known compromises affected Facebook, Google, Twitter in 2013 through an iOS developers forum, affected the undisclosed financial targets in the US in 2014 through Forbes.com website, the Dragonfly campaign targeting multiple US government and critical infrastructure sector in 2016 through third-party suppliers' websites. And the most known attack was the case of the Polish banks in 2017 through the website of the Financial Supervision Authority of Poland. Most of these attacks go undetected or as unknown infection vector because it's very hard to pinpoint the exact patient zero, so to say, in case of a watering hole attack, because all you do is just visiting a website. There is no user interaction, you don't open any email, no phishing link, nothing. Why are watering holes so hard to detect? You think that financial institutions or governmental institutions or military have quite a high degree of security in their networks. So how do this type of attack go undetected? Because as I was saying earlier, unlike spear phishing or phishing, there is no email or other user interaction involved. Unlike direct service or server attacks, there are no logs left behind. The redirection to the compromised website happens only in browser, and most of the times it's highly obfuscated and no signature can be extracted from this attack. Also, it is very important to state that there rarely are two watering hole implants looking the same. Therefore, no signature can be extracted again. These type of attacks are very targeted. They are tailored to a certain group of people, to a certain website. I never seen two watering hole attacks looking the same. Another issue with this type of attack is that most of the times the exploit kits use either 0-day or 1-day vulnerabilities that have no patch issued, or the patch was issued quite recently and the people didn't get the time to patch. The deobfuscation routine for the JavaScript, for the redirecting elements of the HTML runs in browser, and no external antivirus or firewall can see the obfuscated code in order to raise any alarms. The implants make use of anti-analysis techniques to deter automated sandbox analysis. And all known watering hole attacks that have been discovered in post-exploitation stage, long after the actual compromise of the network or the site. As you can see here, I give you two examples. On the left side of the screen, you have the obfuscated JavaScript that performs redirect. On the right screen, on the right side of the screen, you have the deobfuscated JavaScript. This is the same, but on the left side is the actual code that exists in the web page, and on the right side is the actual code that gets executed. As you can see here, the JavaScript creates an iframe which have 1 pixel width, 1 pixel height, style display none. It comes from a very dubious source. It looks for user agents such as Internet Explorer or Opera or Web TV. And also it has anti-analysis technique by setting a timeout to execute the script after 1000 milliseconds. As you can see on the right side, it's very easy to notice the offending elements of the JavaScript, but these are not very obvious in the obfuscated script, which is located on the left side of the screen. So we decided to come with a new approach, and that is detecting the watering holes through artificial intelligence. Because detecting the watering hole in post-exploitation stage is unacceptable in a secure computing environment. We focused on detecting the watering hole in its earliest stage, the redirection stage, which can be performed through various DOM elements such as iframes, document location, or meta refresh. But most often, JavaScript is used to conceal this behavior through obfuscation. Most watering hole attacks employ JavaScript because it allows to obfuscate the code, so nothing is very obvious to the unsuspecting guy. So, in order to conclude our research, we analyzed over 40,000 malicious redirect samples. We were able to determine general behavior metrics such as obfuscation, redirection, anti-analysis capabilities, coding patterns, and typologies of the such so-called code. And by analyzing the HTML and the JavaScript instruction set, we are able to classify instructions based on these metrics and create a model to be used in our machine learning algorithm. Not only instructions give the score, but also their context and placement inside the code, how they interact with other instructions. For instance, if we have a transformation instruction inside a loop, a for or a while, we give it a much higher score than if we had the same transformation operation outside the loop. In order to give a better idea and a better training to our algorithm, we used 30,000 samples to train our algorithm, and the remaining 10,000 were used to test the algorithm. We use a supervised random forest implementation for classification because it uses collection of trees with a random parameter holdout to build models, which very often outperforms individual trees. And the artificial intelligence prediction is used to make the decision whether the DOM element is suspicious or not. A JavaScript and the generic sandbox are used in parallel to analyze the suspicious DOM elements, emulating user interactions in order to evade anti-analysis techniques employed, such as mouse movement, keyboard activity, non-standard screen resolutions, etc. So if there is any inconsistency between artificial intelligence predictions and the sandbox's results, the suspected DOM element is submitted for manual analysis. So we can train the machine learning algorithm furthermore, diminishing the false positives and false negatives rate. We used approximately 10,000 malicious DOM samples and the Alexa Top 1000 websites to test our machine learning algorithm. And during the testing phase, we achieved 100% detection rate for previously unknown implants and 0% false negatives and 0.00023% false positives. This was my presentation. This is my startup. Thank you very much for your time. Have a good day and enjoy DefCamp.
Hello, everybody. My name is Adrian Furtuna. I'm the founder of pentesttools.com. And today, we are going to talk about report writing in penetration testing. So, before we begin, I would like a quick raise of hands. Who of you has ever written a penetration testing report until now? Okay, some of you. And the second question, from a scale of 1 to 10, how much did you enjoy this activity? So, louder, a little bit?
I hate it.
Okay, so I guess this is a 1, from 1 to 10. Some other answers? 3, okay, below 5. Some other answers? Okay. So, yeah, report writing is not nice. As a penetration tester, it's very fun to research cool exploits, attack techniques, to try to break things, to get access, steal data, and so on. But the true thing is that none of this reaches the actual client, but the report. So the report, it's a necessary thing that needs to be done. But we all hate it. And today I will show you a solution to see how we can make this activity easier and less painful. A little bit of background info before. I have about 10 years of experience in ethical hacking and penetration testing. I did found pentesttools.com. I also do some teaching at Polytechnic University of Bucharest. I also did some speaking at some conferences. And about pentesttools.com, it's an online platform which helps companies become resilient against cyber attacks. This is because we offer a self-service platform in which clients can do their own security testing and produce their own reports and so on. We have more than 25 security tools on the platform. About half of them are created by our team, and the other ones are open source tools integrated into the platform. Here is a little bit of historic data. For the last year, we had more than 1 million users. This is according to Google Analytics. We have pretty many customers, we say, from all over the globe. Not quite Romania. And 80% of them are companies, and the others are individuals. But let's get back to pentest reporting. So, what do you do when you have to write a pentest report? The first solution, I couldn't help of not putting this picture, is Control-C, Control-V. So, you actually do a copy-paste from previous reports that you have. But from this, come on, you never did a copy-paste. No. Some problems arise here. So which one was the best version of the report from which you want to copy from? Then, what if you have to write some findings, and some of them are in one report, others are in other reports, and so on? And then, the last thing, the most important, you have to adapt the findings to the current client, not to miss any target data from a previous client to put it in the report of the current client, because you're screwed. Not to mention not to leave the names there, and so on. The second solution would be to write your own report generator tool. I saw and I know that there are several companies who have their own internal tools for report generation. However, you need to have some resources to create such a tool. After you create it, this tool needs to be maintained. There are bugs to be fixed. There are new features that are requested by users, needs to be updated, and so on. Okay, and another solution would be to use a third-party generation tool. There are some existing solutions, and the most significant that I saw are Serpico and Vuln Report. Has anybody in the room worked with any of this? Okay. They can be a solution to the problem. However, there are also some challenges. The main challenge that I see is deployment and data sharing. Imagine that you have a pen test in which there are multiple pen testers working, and this, for instance, you install Serpico, you install it on a laptop, for instance, of one of the users. But you need to share information between those pen testers, and that's a little bit difficult. Each one of these solutions has a learning curve, which can be difficult sometimes. And a main drawback of this solution is that you do the scanning with some tools, you obtain some results, and those results need to be imported into these tools. And these tools need to have the capability to import your findings in your format. The solution that we are proposing here is a cloud-based solution. Actually, is a new feature that we have developed in Pentest tools. As I said previously, so the platform contains multiple scanning tools, so you can run the tools from the platform. The results are also in the platform, and you just need to select which findings you want and click the Generate Report button, and you will get a docx report, so an editable format. Okay, enough talking. Let's do it in action. Let's see it in action. So this is our website. We'll do a login. This is the main dashboard. And for this actual test, we will create a new workspace. Workspaces allow you to group targets based on the project that you're working at. Let's say DefCamp 9. We have added this workspace. We will make it the current workspace. And now let's add some targets. We will add some demo targets. For instance, this is one of ours. Let's add some more. This is from the friends of from Acunetics. And this is one from, this is another, so all of these are online applications that have some vulnerabilities and can be tested without any authorization. Okay, so we have these 3 targets, and we can select all and choose which one of the tools we want to scan with. You see that there are a lot of tools here, split into these categories: information gathering, web application testing, infrastructure testing, and some utilities. And let's say we will do web server scan, light because it's quicker. And here you will see updated they will update in real time the results. What you see here is the summary of the vulnerabilities identified for each target. So one red, one medium, one low for each target. If you want to see them individually, you can go, let's go to this one, for instance. The problem here is that the server software, which is 5310, is affected by multiple vulnerabilities. You also have the links from exploit.db, from exploits where they exist. Insecure client access policy, and so on. You can download this report individually, but what I want to show you right now is that, so we have 3 scans here, each one with their own findings, and right now we have aggregated them into a single view. So here are all the vulnerabilities. You can here you can mark them. For instance, you can mark them as false positive. So here's the difference between pentest tools and other platforms. So in other platforms, you are somehow forced to get the results returned by the scanners. At pentest tools, you have the option of a manual analysis of the results, and you can exclude from the reports the ones that you find that are not interesting or not relevant. You can also mark them as fixed, and somebody is playing with the internet connection. Okay, and let's see the report generation feature. You can select which findings you want to report. And let's say one low. And click on this magical generate report button. And we are waiting for the report to come. Okay, so here is a nice Word report. We can right-click on the table of contents and update it. You see that the findings have been added automatically. And let's go a little bit through it. The client name, table of contents, document control distribution list. These are updated automatically with your information from the platform. Now, the introductory part. You will be able to edit these fields yourself to customize them on your own company and needs. So the background, the objectives of the test, the scope, those tables have been filled automatically. Approach, methodology used. You will also be able to change this as you want. Disclaimer. This is the executive summary, also automatically generated with these graphical things. Also a table with the summary of the results. And here are the findings. So the findings are in this format with finding some evidence, risk, and recommendation. And this iterates through all the findings. This is one with the vulnerabilities, the CVE, the exploit, the affected software, risk recommendation, and so on. And yeah, you will get this report, and you will be able to manually edit it as you want, and just ship it to the client. And I say that this functionality will save about 80% of your reporting time. This is my estimation. And you will also be able to add your own report templates. So if you have your own fonts, colors, paragraphs, table styles, and so on, you will be able to upload them here. Okay, this was the demo. This is a voucher code that we give each year at DefCamp. This year is DefCamp 2018. You can guess what will be next year. You have, if you register with this voucher code, you will get 300 free credits, and you will be able to access the full capabilities of the platform, including this report generation feature. And it will be very useful for us if you give us feedback. So we are constantly developing the platform, and we want to make sure that we are developing in the right direction. Okay, in the end, I want to thank very much my team, which is an awesome group, and also to our advisors, Andrei Pitiș and Diana Olar. And also, I would like to give a big thanks to Orange FAB Romania, which is a great startup accelerator, and they have facilitated us the stand here at DefCamp. And I would also like to thank DefCamp organizers who are doing an excellent job each year at organizing this great conference. So thank you very much, and if you have any questions, we are open.
Thank you. I would like to invite all of the three speakers in front, and it's the Q&A session. I don't want to bribe you or anything, but we do have goodies for the people who are asking awesome questions. So, amazing, more hands. Hello. I said the magic words. Ioana, sorry, we had here a first hand. Here. Hello? Can you raise your hand, please, so she can see you? And then?
Cool. I have a question for Adrian. Does your report generation tool allow us to manually introduce the findings, or it could just generate findings from your framework?
Yeah. So I forgot to mention that. You can do a new finding here, and you also have finding templates with predefined descriptions, recommendations for each finding. And in findings, you can do a new finding from template, SQL injection. You can choose the target to which applies and add it, and then you will be able to add it to your report.
So it basically could be used like a standalone report generation tool without the need of your scanners, right?
Yes, exactly. And we also add the ability to import scan results from external tools.
Cool, thank you.
Okay, thank you.
Thank you. Our next question, Ioana. Our second question will be the red jacket, and then afterwards, there was a hand there, and then we'll be coming to the front row.
I would like to ask if you are planning maybe to implement the DefCamp tool in Pentest tool, because it seems like it could complement. But no, actually my questions are to the DefCamp related to?
Sorry, there is an answer to the first question. If you want to mention about.
Both tools are included in the BIS threat map, the orange product, and this answers to your question. Yeah.
No, my question I had that I thought about were if you have a product and what they call an MVP, a minimum viable product, so a demo or something that you can show us, because I remember also last year you presented the same concept.
It was 2 years ago.
2 years ago.
And right now we have implemented the product. We have the startup in the Orange FAB acceleration program, and it's already included in BIS threat map. So yeah.
And the second question was about the data set. You said you had 40,000.
Yeah, 40,000 samples.
And the question is how, from where did you get such data set, and what's the quality of the data set? Are you sure that it's only malicious
Open
JavaScript?
source, personal research, and from the community.
Mm-hmm. Okay, thank you.
Thank you. If you have samples, please feel free to contribute.
Thank you. Going for the third question there. And our last question will be in the front row.
Hi, this is a question for Alex from Absolute. So I was wondering, what's the latency constraint for the containers, right? So how close do they have to be to the client? Because, you know, we've all played with like X forwarding and stuff. So have you sort of looked at that?
Yeah, we are currently running performance tests and analyzing this. We are working to employ a geo-aware deployment of containers, so it should be as close as possible to the users. We don't have yet metrics of what is the maximum latency to get a nice user experience. We don't have the metrics yet, but we're working on making it as close as possible to the users.
And another question is, why containers and not VMs, right? I mean, it seems like if you want to get better security, you have to get VMs, right?
Well, the containers is at the end of the day hosted in a VM. It's just an additional layer of isolation and
so
sandboxing.
You don't have multiple containers in the same VM?
Yes, we have. We have multiple containers in the same VM, but only the containers that belong to the same tenant are being kept there. We don't cross mix containers of different customers. So we do tenant-level isolation by just managing containers from the same customer into the same VM.
So you have one VM per user of the platform, right? So if I have like 1,000
No,
employees,
I have one container per user.
One container?
Per user that is being started when a user needs a session.
So if the CEO
I'm
gets
sorry,
a...
I will have to cut the question because we have still one more question.
Yeah.
Thank you. And I invite you to have a networking session and a talk afterwards, and that's valid for anyone else. And the last question here in front, thank you.
Hi, actually it's a bit related to the question before. I was curious also for the Absolute, I'm here, how the performance is affected in large scale organizations, I don't know, like bank with all sorts of security, and how is this, I didn't understand fully the concept. Does it use X forwarding, or how do you actually get the session? And I'm curious, how could you make it performant in the multiple thousands of users environment?
Yeah. First, let's start with the, so we are transferring the X session from the container, and we are transforming it into PNG at the end of the day in the client. We are using a technology to do this. It's not our own technology, we are using a technology. In terms of performance, bandwidth could or could not impose a problem. We are taking about 0.5 gigabyte per hour on average use if you stay all the time in Absolute. Of course, at large scale, we can also work on reducing a little bit the bandwidth by compressing more the images and have a less quality of if the bandwidth is a problem inside corporate premises.
Yeah, I was talking bandwidth and memory CPU wise. Even so.
How we scale the infrastructure on
Can you scale it horizontally also?
We have an elastic infrastructure that scales both horizontally and vertically, depending on what is the use case exactly.
Okay.
We
Thank
can
you.
Speak
Thank
in
you,
more.
Yeah,
thank
thank
you
you.
very much. Thank you.